Hello, okay, and let's today discuss about the expression or derivation for your metacentric height. Okay, in previous class we have just I have just wrote this value and we have proceed. Now we are gonna discuss this how this expression has come. That is, gm equal to I by b minus bg. Okay, let's go for it. So for your better understanding, I have drawn an isometric view of a shape. In this, your imagination is very important. Three-dimensional imaginations are very important. Okay, so just to make things clear, let us say this is your front view. If this is your front view, how does it look? Sir, this front view is looking like this. Very good. Okay. Now this is your top view. When you look like this, it's the top view. Can I show the top view here? No, because it is a two-dimensional figure, two-dimensional object, and this is plane to the paper, plane to your board. So I cannot draw the two-dimensional plane. Hence, what I'll do, I will tilt it like this. I will tilt it by 90 degrees. So this is my three-dimensional top view. Okay, this is your top view. Now these two things you should remember. Okay, this is going to be very much helpful in our analysis. Understood? Very good. So this is the front view of the shape. How the top view looks? So the top view looks something like this. Very good. Because this is the top view, like when you watch from the top. And here it is nothing but a rectangle. Okay, clear? Very good. Now, initially this shape, this portion is at static equilibrium. When I am talking about static equilibrium, that means the center of buoyancy B and the centroid, which is G, are acting on the same line. That means what is the F net here? 0. The F net is 0. No F net is now, because it is in, this is the condition of flotation where F net has to be 0. So that's why these two are in same line. That hence your moment there is no moment now, no moment at all. Now what you have done is you have given it some angular displacement. Because of this angular displacement, whatever the force you have given, this particular shape has now tilted by some angle theta. It has tilted. Now because it has tilted, what are the change happened? The right side has now more submerged and left side is less submerged. Previously, both the left and right side were equally submerged, but now the right side has more submerged, more gone into the water, and left side has come up the water, come above the water. How much it has come down, sir? How much it has come below the water? See, this much portion it has come extra, this much portion has come below the water, and this much portion on the left hand side, equal amount of portion only has tilted up, that is came out of the water. Okay, came out of the water. How much portion came below? Same portion only came up. Okay, very good. Can you imagine which kind of shape is this? This is a wedge prism, WDGE, wedge prism shape. Okay, now let us name it. Say this is my A, okay, and this is B. Here also this is A, this is D. But now here the A and B on the same line. Now it has changed. Let us say it has come to A prime, it has come to D prime, and this centroid is O. This is O. Okay, center of gravity does not change. G. This was your previous center of buoyancy B. Now because more portion is now on the right hand side, so the center of buoyancy has shifted towards right. Center of buoyancy has shifted towards left. Let us say here is your now center of buoyancy. Okay, and if we extend the center of buoyancy, it will meet at a point, we call it as what? Metacenter, and the angle of field theta. Theta is the angle of field. The same angle only it will make here. This is also theta. Okay, understood the geometry as of now. See, I am going slow and steady. Okay, up to this much you understood. Next, try to go for the next concept. So because now DOD prime portion is below the water, extra below the water, That means because of DOD prime, there will be some extra buoyancy force which is acting upward. Okay, that's what we call buoyancy, gain in buoyancy. That we call what? Gain in buoyancy. So there will be some gain in buoyancy because of this ABO dash. So let us write it FB, gain in buoyancy. So let us say this is the imaginary portion which should have been here, but because you have tilted, some portion has gone that side, this portion has lifted up. So there is something known as loss of buoyancy, FBL. So this is your loss of buoyancy. Okay? Gain in buoyancy FBG, loss in buoyancy FBL. Sir, can you draw it properly? It is becoming little messy. Definitely I am gonna draw. Okay? You just pay attention. That's all is required. That's all I am requesting you. So this is your O, this is your D prime, A prime, this is your A. Okay? At this FBG, gain in buoyancy, here it is FBL, loss in buoyancy. So these two are what? These two are what? Two forces are separated by some distance. Separated by some distance. Sir, where the buoyancy force will act? Sir, it will act on the centroid of the displaced volume. Centroid of the displaced volume. Let us say from O, the centroid of displaced volume is at a distance x. Is at a distance x. From here also, the center of displaced volume is at a distance of x. Need not to say after the angular displacement, after the tilt, DOD prime has come below the water and AOA prime has come above the water. These two wedge shaped prism are equal. Okay, are similar, are very similar. Okay, understood? So this one you got it. So what will be the couple if these two are forming a couple, na? FBG and DFB. Sir, is their magnitude same? Exactly. FBG equal to FBL. Both of their magnitude are same. Their magnitude is same. Okay. So magnitude is same. Good. Very good. Now let us keep it here only. Okay. Now coming to this part. Initially there was no buoyancy. Initially there was no F net. Now there is some change in moment. There is a change in moment because of the shift in buoyancy. There is a change in moment because of the shift in buoyancy. So this force FB, which is acting vertically upward here FB is acting vertically upward. This is your G, where W, entire mass of the body, is concentrated. This FB, which is acting at a distance of BB dash, the value of this couple must be, the value of this couple generated by the buoyancy force must be equal to the value of these couple produced by gain and loss of buoyancy. Produced by this gain and loss of buoyancy, the couple must be equal to the couple produced, a couple change because of the shift in buoyancy, center of buoyancy. Why same, sir? Why it will be same? If it won't be same, how you are going to get a restoring couple? This M is above G, right? Means it's a stable equilibrium. Stable equilibrium mein again you will have a restoring couple which will bring the body to the original position. So that's why the couple change due to the shift in buoyancy must be equal to the total couple because of the gain DOD prime, gain in buoyancy and the loss in buoyancy. Okay, are you getting the point? These two has to be same. Okay, sir, we understood. Please write this, otherwise this will be problem. Okay, so I will write here couple change in moment. I will write change in moment. Okay, due to shift in center of buoyancy. Due to shift in, yes, bolo, Hare Baba bolo, center of buoyancy. What is this couple, sir? This couple is your FB multiply B dash. FB multiply BB dash. That is your couple. Now, let me draw this diagram. Let me draw this diagram. Okay, this angle is your theta. This is your G. This is your M. That is metacentric height. GM. Okay, understood? This is your this is your BM. B dash M. Okay, B dash M. Can you tell me what will be the value of BB dash? Yes, can you tell me what is the value of BB dash? Take sin theta, Baba. Take sin theta. What will get, sir? I will get BB dash by BM. BB dash by BM. I will say very good. So what is your BB dash, sir? BB dash is BM multiply sin theta. BM multiply sin theta for a very small angle theta. For a very small angle theta. What is sin theta? Sir, for a very small angle theta, sin theta is theta itself. That means your BB dash is equal to how much? Sir, BB dash equal to BM into theta. So, now this couple, let me write C BB dash, couple BB dash is equal to FB multiply this. That is your BM into theta. BM into theta. Simple. Very good. What is force of buoyancy? Sir, force of buoyancy is the density of fluid multiply G multiply volume displaced. Volume displaced by this portion, total portion. Volume displaced multiply BM multiply theta. Super. Fantastic. So this is your CBB dash. We got this value. This is your equation 1. So this value must be equal to the couple generated by the A prime O and D prime O. Okay. I am requesting you to note it down because I have to erase it again. Okay. Pause the video and note it down. Now we have to calculate the couple because of the D prime going into the water and A prime coming out of the water. That couple we have to find. But we don't know how much is the value. We don't know. It can be any angle, right? Theta may be anything. This value may be anything which I don't know. In such cases, what we do? We take an elementary strip. We always take an elementary strip. Then we find it for the dx, integrate it for the entire value. Okay? Same process only we are going to use. Now let me draw this again. Okay? So this is how it was. This is how it was. Pay attention, Pay attention. This is your O, A dash. This is B, this is B dash. Okay. Now I am taking elementary strip. Now I am taking an elementary strip. Okay. So let us say this is the elementary strip I am taking. So where you are taking the elementary strip? I am taking the elementary strip where the center of buoyancy was lying for this FBG. So that means I am taking this elementary strip at a distance, how much? At a distance x. I am taking this elementary strip at a distance x. What is the thickness of elementary strip? Sir, the thickness of the elementary strip is dx. The elementary strip thickness is how much? Your dx. Superb. Okay. Very good. That means if I have to show you the elementary strip value, see, I am showing in the other side. It's like this. So this is your elementary strip of thickness dx, which is throughout. Which is throughout the pura total. So this height, this is your dx, this is your L length, total length. Total length of the ship is how much? This is L. Total length is L. Okay? So this is your dx. How much is this height? This height is h. We don't know. We don't know the height h. We will find the height h. Okay? And let us say this angle is theta. This angle is how much? Theta. Very good. So that means same strip also I will be taking this side. Ditto strip. At what distance? X distance. X distance. That means now the buoyancy force acting here is your BFB. Okay, same buoyancy force will be acting here also, na? That is your DFB. Both are symmetrical, so both the forces, the magnitude of both the forces are same. Magnitude of both the forces are same. Okay, very good. Now let me draw this triangle here. Let me draw the triangle here because your sir wants to find the value of h. This is your dx, this angle is theta, this value is how much? So this value is x. Okay, superb. O, d, d dash, take tan theta. Sir, what is tan theta? H upon your x. So what is h? Sir, h equal to x multiply tan theta. Superb. So for any small angle theta, for small theta, what is your tan theta? Sir, for any small angle theta, tan theta is theta. Tan theta is theta itself. So this implies h is equal to what I got? Sir, you got h equal to x into theta. You got h equal to x into theta. So now I know the height of the elementary strip. So what will be my area? Okay, elementary strip I am writing. Heading I am giving elementary strip. Okay. So what is the area of your elementary strip? TA. Sir, area of the elementary strip is going to be h multiplied by dx. Okay, what is h? Sir, h already we got x into theta. Okay, x into theta into dx. Very good. Then what is going to be your volume? Volume of the elementary strip dv. Sir, volume of the elementary strip is x theta into dx multiplied the L. That is your, this is your h. So how much you got? Sir, we got x multiply theta multiply dx multiply L. This is the volume of the elementary strip. Volume of the elementary strip. Now, what is the force of buoyancy? What is the force of buoyancy on your elementary strip? Sir, the force of buoyancy is dFb, and we know the force is nothing but the density of fluid G multiply the volume displaced. Multiply the volume displaced. Superb. Very good. Very good. So density of fluid G multiply dV. What is your dV? So dV is equal to x theta dx into L. This is your dV. Okay, got it? Understood? Super. So dFb. So this dFb on both the sides na? Are papa, yes sir, no? Okay, this dFb is for both the sides same. So now I will take the couple. Now I will take couple. So couple due to the elementary strip. Elementary strip. Okay. How much is the couple? Sir, couple is nothing but dFb multiply x. But see this, what is the total distance between these two? Sir, x into x. The total distance is 2x. The total distance is 2x. Super. Very good. Fantastic. So write that dFb into 2x. What is your dFb? Sir, just now you wrote the dFb is rho f multiply g multiply x dot theta into dx into L multiply 2x. This is your couple because of the elementary strip. Now we need the total couple. Total couple because of the going in of DO D prime and coming in out of AO A dash. You please note it down. I need to erase it. Note it down. What is the total couple? Total couple due to going in of DO A dash and coming out of AO A dash. Integrate. So take these things common. Rho f g theta 2 common, integration of x square into L dx. Integration of x square into L dx. Now very important. Try and listen. Remember, initially I told you this is the front view, this is the top view. You cannot see the top view as it is perpendicular to the plane of paper. So we write like this. Okay, that drawing only I am doing. See, this is what my top view I have got. This is what the top view I have got, and this is my axis. This only I am showing it here. So what this axis you are taking, sir? Some people take YY, but this axis is my longitudinal axis. Hence, I will take this axis as XX, and this transverse axis I will take as YY. Okay? So this is my xx axis or longitudinal axis where rolling happens in this. Okay. So now this is my strip. This is your strip dx. This is the strip dx. Dx length. What is the length? L. What is the thickness? Dx. Same on the other side also. Yes or no? Other side also you have to dx and length is L. What distance? Sir, at a distance x. At a distance x. Okay. Try to understand. Try to understand. What will be this strip's area? What will be dA here? So this strip's area will be L into dx. Area is how much? L into dx. Now I take area moment. See, force moment is different. Force moment is force into perpendicular distance. This is I am taking area moment. Area moment will be what? Area moment dm equal to, sir, dA into the perpendicular distance. What is the perpendicular distance? dA into x, or I'll write x into dA. So this is what? Moment. This is what? Moment. So here, if I'll apply more, so that means this total strip which is moving, entire moment I am taking. Already x into dA. If I multiply one more x into this, so what you will get? What is this value? This is your moment. Moment of moment. What is that? That is your moment of inertia. So x into dA means what? X square dA. Yes or no? X square dA. So here I got rho f g theta 2 multiply x square. What is L dx? dA. So what is your x square dA? Is the moment of inertia. X square dA is what? Your moment of inertia. You got it. Sir, 2 is there. 2 is because your left hand side also you have a strip. Your left hand side also you have a strip. So the total I got here, this couple, because of this elementary strip ES is equal to rho f g theta and your moment of inertia multiply moment of inertia, and this couple value is equal to the change in moment due of the buoyant force due to the displacement in BB dash. That is what equation 1. This is your equation 2. Now equation 1 and equation 2 we are going to balance. Okay. Again note it down. Balance your equation 1 and equation 2. That is the couple due to your buoyant force is equal to the couple produced because of the your elementary strip. That is we total wedge we have took. Okay. This is how much you got, sir. You got rho f into g multiply the volume displaced into BB prime, which you found, sir. You found it at BM into theta. This is what you found. Very, very good. CES, how much we got, sir? You got rho f multiply g. Okay, this is rho f into g multiply theta, and you got I naught. Correct? This is what you have got. Now, sir, now it is very, very simple. Very, very simple. So rho f g cancel, theta cancel. So what you got, sir? We got Bm multiplied by this volume is equal to I naught. So that means we got Bm is equal to I naught upon V. Bm equal to I naught upon V. But I don't need Bm. What I need? Metacentric height. What is metacentric height? Gm is the metacentric height. So what is Bm? Sir, Bm is equal to Bg plus Gm. Bm is equal to Bg plus Gm is equal to I naught by V. This implies metacentric height Gm is equal to I naught by V minus Bg. This is the expression for metacentric height. Okay. So if its 3D imagination is required, if you don't understand it, try watching it again. Okay. Any doubts, please write in the comment box. Okay. And do subscribe to the channel, like and share with your friends, and have a great day ahead. Thanks a lot for watching this session with me.